Okay. All right. So this is the homework we were just talking about. It's not in Canvas yet. I think I give you a week or two for each one of these. We're in no rush. I'd rather have you learn it than slap out a lot of homework. You know, it's more important that you learn, in my view, than the grades you get. And I have a policy that if you don't get the grades you want, come see me. We'll get you the grades you want, but you have to convince me you've learned what you need to learn too. Okay. So in addition to, because I know what you need out there. Maybe you do, maybe you don't, but there are some things that if nothing else, there's an attitude you need. It's like, I don't know everything, but I can't ask every single question. You have to show that you know how to peel back the covers and solve the problem. Because sometimes they'll give you a problem just to see if you can solve it. Okay. So that's a real deal. All right. Tonight, what we'll be doing is our good friend, the notebook. It's around here somewhere. I know it was. Here it is. Okay. Now, tonight, what I will be doing is this is one of those nights where you just get a piece of paper and you start writing down some of these terms and some of this stuff that we're going to expose you to. This will probably be the only time I talk about some of this stuff, but this is the sort of thing that you will be using in industry, depending on what your expertise is. And some of the stuff that I'll be talking about spans the spectrum of security, databases, operating systems, networking, all of it. Okay, so some of this is needed for the whole discipline. Okay, so what I want to do is introduce you to a few commands that we haven't really touched on, but are part of this tool chain. And I will tell you where these commands kind of show up in industry and when you might need them. Okay. And to start with, I think what I will do is use this one. It's called the Berkeley packet filter. And it's called extended Berkeley packet filter.io. Now, this is definitely the only time I'll be talking to you about this. The Berkeley packet filter is the best way I would describe it as a shim that you put in, and you can basically imagine your heart is beating, and I put a shim in your heart and I open it up and I actually see the blood moving. That's what this packet filter does. Okay. It actually lets you see what's going on at a very deep level on your networking or your security, and observability is in the sense of what's going on in my kernel. And what this company has done is the extended Berkeley packet filter is open source. You do not install it on production machines. Can you imagine why? If you can open an artery into something and somebody's put a dev tool on their production box, you open the artery and you can have a nice look at payroll or whatever else you want to see. So this does not go into production. Okay. You use it once things are out there. Okay. Now, this is where it's being used for network insights and security auditing and Cloudflare. Anybody heard of Cloudflare? 1.1.1.1 DNS. Yeah. And this is the one I thought was fun. Meta uses EBF to process and load and balance every packet coming into their data center. Think about that just for a second. Every packet gets load balanced. That's why your images go so fast when you bring your images up in Facebook, because it's cached somewhere. Okay. This is pretty complex stuff, and it's way out there. But this packet filter does give you the ability to do some really cool stuff, and you just, wow, there's a lot more to it. You do not need to use their website, but what's nice about their website is they give you an idea of how it works, and they walk you through things, and they give you a nice little intro, how it works, verification. And then down here at the very end, I don't know if it's on this particular one or not, might not be, is BCC, BFT, the Go Library. I missed it. GDB, your GNU debugger, is used in this. So the debugging tool that you're learning is part of this tool chain. Okay. So you're learning piece parts of this thing. Okay. All right. Now let's look at a command that's called nm. Okay. It says no such file exists. So let's create one. ASM. And let's do cat hello.c. There we go. So let's just do that. Let's just take GCC hello C. And remember, if I use no flags, what does it end up as? A.out, right? So now I'll use nm A.out. Cool. What am I looking at? What is nm short for? Well, man space nm. It is part of list symbols from object files. I think nm stands for something. I don't remember what, but it's telling you the symbols from the object file. Okay. So this is one of those commands that you would just write down and say, I don't need to know this right now. But in the future, if somebody says, hey, we need to profile your code better, then maybe this might be one of the things in the many different things that we'll use. Okay. Right. And here's another one. LDD. Man, LDD. Print shared object dependencies. glib.c. How many have heard of glib? Maybe, maybe not, unless you're a Linux person. It's actually glib.so, as in shared object. Many of the things you compile on Linux, you connect the shared object to your code, so you don't have to rewrite the wheel. Okay. And this shared object, what's in it? Is it corrupted? Is something wrong with it? How do you know? This is a tool, LDD, can help you see the object dependencies of how things are connected to your shared object. Okay. So if I do, and they're showing you how it's working here, one of them. I'm going to do LDD on A.out here. And it shows you, oh, that's not too complex. It's showing me that I'm using this shared library and this shared library and that shared library for Hello World. What are those shared libraries? They're part of the stdio. Okay, so we have our source code that goes down 800 levels deep, and then we have our object code that gets compiled. Okay. All right. So LDD is one, and let's see here. I think what I want to do is show you this one. This probably won't work. I didn't install it on the production box for the same reason you don't install back Berkeley packet filter. So I'll do this. Okay, there we go.
So you ran the nm command on a .o file, an object, is that an object?
Yes, that because it a dot out. I think there's a flag for it. There's like 95 flags to each one of these commands for very specific use cases. The one I want to show you now is called dtrace, and I'm not going to do anything with it other than to say that dtrace came from Sun Microsystems, and it was the cat's meow when it came to debugging the kernel. And everybody in the Linux system said, hey, how come we don't have dtrace? It took them years to get something that would work like dtrace in Linux. And it just took a long time because it's a very complex problem to solve. And to install this on your Linux box, it's part of this system right here. I don't know if you can see it. It's called System Tap STD Dev. Okay. So when you install dtrace, it will work like all the books from the 90s and the early aughts on Sun Microsystems. The dtrace is quite powerful. Again, you don't put it on a production box. I put it on my notebook here, not on the Jeremy box for the same reason. Okay. It's a tool that you can do very, very advanced understanding of what is going on in your kernel. Okay. And you're going, oh, I'll never need this. Oh, yeah, you're right. You'll never need it until you need it. And then you wish you knew it. That's just the way it is in this business. You never know what you need to know until you know you don't know it. And then there you go. And it's like, where's the book? You got to get good at learning. And you also have to be good at saying, I really don't know anything about this. How long is it going to take me to learn to be effective? I can't teach you how to do that. That is a very important skill on how do you appraise your own talent that, hey, I really don't know anything about this, but I think I can learn it within maybe a week or so. Okay, so you just put that into your buffer of your project management and saying, okay, I got to do some serious homework. I got to get to speed on this. Okay. That will happen to you all the time. Okay. All right. So that one. And then there's a couple we do have that are on here. It's called mem usage. These you can play with. They're not going to hurt anything. They just inspect. Whoops. I guess I need to run high or something. What did I call it? Not found. Oh. Yeah. /a.out. There we go. Mem usage. So it's showing you what it's doing. So you can use mem usage on your own code. Yes.
Are you typing on your other on the
Oh, thank you. There we go. Thank you. Thank you. So mem usage, and then I typed in / the executable, and then it shows you what it's doing, okay, or what it actually did for the memory use. There's a command that works with this. It's called mem usage stat, and it will collect the data over time. And then you can run these things called heat graphs or flame graphs. I'll leave you to go look that up because flame graphs are all the rage for web development right now. Where are my hotspots in my website? In other words, things that are slow. And flame graphs and heat graphs are ways to visually represent that so you can explain it to your boss what things are going on. Okay. Bosses like pretty pictures. Okay. mem usage, and then there's mtrace, which does similar things. Okay, wrong number of arguments. No memory leaks. So this gives you a quick test on your code to see if you have memory leaks. Now, if you write in C and C++, there is a call called malloc, memory allocation. Many programmers for years did a memory allocation and then they never would do the memory deallocate, because when the program would stop running, it would deallocate it automatically. This is fine, except when you write code that's running for a long time, like a database server. When I was at Foster's, we ran Oracle on AIX. Oracle runs on everything. Therefore, it doesn't run well on anything. Okay. So we had AIX machines that had uptime in years, but we had to drop the database every quarter. Just drop the database, turn it off, turn it back on again, because it would do this memory leak thing. It was all part of the asynchronous IO, and it'd sit there, it'd use it up, it gets slower and slower and slower. And basically, okay, all right, we need our downtime this month, and then turn the database off. It reallocates the memory, and then it's fast again, and then over time. But that's an example of a memory leak that causes a performance issue. Okay. mtrace is one way to look at these things. Okay. M usage, mtrace. And then there's this PLDD. This is invalid process. This is actually this is for a longer running process. What this means is process ID of your shared libraries. So if I'm running something, I can attach this to a process ID. All operating systems have a process ID. Okay. And I see this as coming upon a blank stare here. This is very much a, okay. Ready to do some deep dive? Have some fun. What's happening is that when I run something, let me go to my machine in my office and show you exactly what I'm talking about. All right, let me bring this screen up over here. Try to make this bigger so you can see it. As you can see, I've got this thing called sock spice. And you see a bunch of numbers in here. These are my process IDs. Now, what is this thing? What am I doing? Well, this gives me the ability to do this. I'm using a Spice JavaScript client that's connected to a proxy on my server in my office. And it's mapping all the traffic from the virtual machine into HTTP via a proxy. So I can actually look at my OpenSUSE VM on my box in the back room. And you're all lost. That's okay. I'll get there. Is it what's happening is that I am now connected, but there's all this stuff going on in the middle that allows me to have this screen displayed in my browser on this machine. On Windows, we have this thing called the event viewer, right? How many have played with this? Event viewer or task manager. Okay. Maybe I'll just use task manager. That's probably a better task manager. There you go, folks. Processes. Those processes are tied to numbers. And if you delete a particular number, that process will go away. Okay, you can kill it, performance, services, you do all this fun stuff. This is in your Windows box. Play with it. This is part of what assembler is all about, is what's going on in the guts of my computer. Okay, and same thing on the Linux box. And what I am showing you is the proxy server that I've got running here. And if I do process -ef grep for WebSockets, there they are. There's all my processes. And then grep -v grep. That's just an interview question. If you go in for a Linux, they may ask you what grep -v grep does, but don't worry about it. So my process IDs are right here. This is telling me what's going on. So the PLDD command will tie to a specific process ID that's running on my machine and give me some history about it. Okay. Like I said, I'm just giving you this today so you can write it down, put it on the shelf somewhere, think about it later. But this is the kind of thing that you can use. Hey, I need to go learn something. Rather than watching 2-hour brainless TV, spend 2 hours learning about the process ID chain and how it works in your operating system of choice. Call it edutainment, I guess, instead of just mindless entertainment. Not to say that's bad. It's just a different way to see things. Bring this back over here. All right, there's that one. And then the two that I will kind of stop with here, and we'll start playing with some labs, is prof, whoops, and sprof. Yeah, just sprof, excuse me, as in profiling, okay? As gprof, that's it, gprof and sprof, okay? Now, these, the best way to learn about these is you say man gprof and read about it. gprof, display call graph and profile the data. So what calls do we have in our main and our foo-c and our foo.h? Do you suppose you could use gprof to see how those calls work? Yeah. So what's sprof do? Man sprof. Read and display shared object profiling data. Now, when we do our main C, foo-c, and foo.h, does it have any shared objects? Yes, because we're using stdio. So we could look and see how the shared objects are working with our code. Okay. This is a interesting time to have a class. Totally get it. And so the prof is one, gprof is one you can definitely play with in this class, NM. And the last one is obj dump. Okay. And do man on obj dump, object obj. And it tells you like from object files. This is kind of like NM, but not. So we'll say obj dump a.out. Whoops. Ob. I can't type today. Oh, look. Click. Can you do an obj dump with the Intel assembler? Make it output the Intel. How would you find out? That. So go find out. Can I make it disassemble according to some other assembler? Or is it, are you stuck with GAS only? I would encourage you to play with these commands with your code in this class. Even if you don't understand what the output is, at least you are doing something. I go, hey, I don't know what this does, but it looks kind of cool. And it might get you curious and figure out what's going on. Okay. It's how you learn some of the weird, obtuse stuff. I have two more I'll show you that are just general troubleshooting type things. A lot of information in here, huh? How do you want to display it? Look at this. This is pretty crazy. So I can use Object to display my running code into another flavor of chip architecture. Okay, so I can look at it as ELF, which is kind of the default we get on Linux, ELF32, and then all these other ones. So let's pick one that's very different. Let's use. Now, Verilog is a tool that's used. It's a commercial tool that's used for, shall we say, FPGAs, where you actually, instead of compiling source code, you compile silicon. So you write your hardware description language, and then you compile that to a chip, and then you run your chip. And there's one of the big game changers in the world right now is programmable FPGA. So you have a chip that does something specific. You run your hardware description language, you generate your chip, you put that chip into a Cisco router. And all of a sudden you need an update. You go back, you run a new HDL, and you just put that new code on that same chip. Okay. That's what makes Cisco so fast, is it's very hardware based. Also makes it hard to update. One mistake, you bricked your whole thing. Okay. So I'm going to encourage you to play with these, see if you can just have some fun with it. Okay. Again, I'm not going to be testing you on any of this stuff. Okay? This is just for your general edification, knowing that, okay, we're going to learn assembler, and there's this little tiny thing that we learned about assembler, but what's really out there is way, way, way bigger than what you're going to learn in school, even a 4-year school, 4-year. Okay. Unless you major in computer hardware engineering, you'll get into more of this sort of thing. Okay. Then the last two I want to show you is LSOF. LSOF is not specifically a tool in the assembler arena. It simply stands for list open files. These are all the open files that happen to be running on this computer at this time. That's all it does. List open files, and it's got a bunch of commands to it. So if you do man LSOF, look at all those flags. You can do all sorts of things. You can say list open file by user. I believe. I think that's it. Yep, those are all the open files I have. So you can put in your username. So who's logged in? I see Kevin's logged in as SSH here, and put in Kevin. And but won't let me wildcard it. So I would need the EBIN. So notice when I do W, I only get truncates it, doesn't it? If I type in who, I get the full thing. Now, you guys are folks are logged in, right? How come I don't see you here? This came up in the Linux class. This is actually really kind of fun. You're there, but you can't see it from the command line per se. It's here. And then here. This is a log file to the Jupyter Notebook that's being stored in var log, I believe. So I can go through and find out where your terminals are and what files are open. So pointers to pointers to pointers to pointers to pointers. Where am I? That's, you get confused. Okay. Now Kevin's logged in through SSH. Okay? You could all log in through SSH. It's just the straight command line without the pretty GUI on the through the Jupyter Notebook. Okay. So list open files. That one is very handy. It's usually installed by default. Not always, but on a Linux box. I don't know if Mac has it or not. I don't know what Windows has in the equivalent. Not sure. And then the last one I want to show you in this category is where did I write it? Oh yeah, PIDOF. Process ID of. And let's find something that's running. List open file. Whoops. Fine. I'll pick one of me here. And let's see here. FIFO. Pipes are open. That's pretty cool. So here's my process ID. And so I'll say process ID of. Let's go up to something that's like this one. See if that works. Oh yeah, that's not going to work. Well, that's not right. But anyway, I'll have to play around with this. My cut buffer doesn't behave right.
And see if anybody's has nano open right. Said you should see if anybody has nano open right now.
Oh yeah, that's a nice way to do it. Do LSOF nano, right? And then that would be
No.
but you just do it. I get to do it that way. Do everything and then just grep
Yeah. That's
for nano. This does everything. Okay, and we can see somebody found the nano name. I renamed it to no nano just for fun. I didn't delete the file. All I did is root was rename it. So if you want to use nano, it's out there. It's just called no nano. Have some fun with it. So you probably were looking at my history to find out doing that. Or did you just
no, I looked at for the symbolic links.
Look at the symlinks. Yeah, that is true. Yeah, there's symlinks and the Etsy alternatives and all that good stuff. Yeah, that works. Yeah. So fun. So that's what we just talked about. The first, 35 minutes here is stuff you probably won't use very regularly in your world of, hey, I'm working at a school district and I'm doing a little bit of everything. I really doubt you'll need to profile code if you're a system administrator for a school district. Okay, you're not gonna have the time. You're gonna have everybody yelling, and my printer doesn't work. If you check the paper, you know, you're gonna get those types of questions. That's where you're gonna start. But if you stay informed about where you want your job to go, and you talk intelligently about that job, you'll be a prime candidate for that job. Okay. And it doesn't always work to say, I deserve that. That might work if you've got a proven track record. But if you don't have a proven track record, then no, don't do that. Okay. All right. So what I want to do now is go back to our labs and talk about these. Now I've put them here, but I haven't put them in Canvas yet. Okay. Take a few seconds to look at this. I'll make it bigger. So we're using the main C, foo C, and foo H, creating a new folder. And basically we're going to use scanf to capture something. And we're going to pass that to foo, so it gets added and then brought back. How long do you think it would take for you to figure that out? 1 hour? 2 weeks? A week? A month? A week?
Yeah.
Because remember, this is nothing more than functions. And how do you use functions? And you're all experts with functions. You've had 2 programming classes. Okay. So where would I add a function that allows me to pass the number and bring it back? Maybe a week and a half. We'll have a couple sessions, then I'll give you hints between now and then. But here's the clue. Yes, I will eventually help you get there. But you won't get the job if you wait for my answer. Okay. You may get the grade, that's fine. I'm pretty easy grader. All right. And then lab 6, it's the same idea. It's just that we're using argv argc to gather the data, and the fix me, basically, if the count in our case is not equal to 2, display an error, because we want the name of the code and then the value passed. But we're not going to do any crazy checks for ampersands and then hashtags and special characters. Okay, so it'll be pretty primitive as far as, you know, but it's enough to say, okay, here's the command line, here's the value 7 that I want to push to foo, and it comes back and it gets added to 8 and displayed on the screen. Okay, that's lab 6. And then lab 7, which I'm not done with yet, is you're taking your main C, your foo C, and foo H. You're going to get a number using our VRC, and you'll pass it to foo H, maybe, to do a factorial on that number. So you'd want a smaller number so you don't overrun your integers, because integers can get to be, you know, 32K. That's plenty big enough for what we're playing with. We don't need to do double wide words and all that stuff. We could make this a double and have a much bigger number, but that's not the point. The point is, how do we add code that is working and turn it into a function that we can call? Okay, that's where we're going over the next couple of weeks, 3 weeks maybe. And then we will take what we're learning in chapter 4 by unwinding the compile flags to get assembler source closer and closer to what we want. So maybe we can pick the very first one, main.c, foo-c, and foo-h, and convert that just into straight assembler. Okay, that's kind of where we're going. Okay, so if you walk through lab 4 and you do all the stuff in there, that's the groundwork that you're going to need for the lab 8 and so on. Okay, that's kind of where we're headed. All right, so you're going to learn how this kind of fits together, and then of course everything we'll be doing, we want to be able to run it through GDB, play with it, poke on it, look at some memory addresses, because one of the things you haven't quite yet discovered is where's the start point of your program? Is it always the same? Based on, we're on a shared server. We always get different memory when we log in. But was your code always going to start in the same place? And if that's the case, then how does it address things? Just some things to think about as we're moving on. Okay. All right. So now that we've done all this fun stuff, let's just take the rest of the time today and bring up those commands that I showed you, the ones we were talking about, and play with them on the Jeremy box to see what you can see. Okay. Pick the simplest program that you've got out there, the hello world, compile it, play with it. And I just did the hello world and turned it into an A like that. So I could actually do things like mem usage here and get that nice pretty screen. Okay. So play with that. What does that do to your mem.h? How does it look, or your memory.c with your foo.c and so on? How does it display? Does it show those things in there? Be curious, because this is how you learn this stuff. If you're going to wait for me to give you the answers, then that's fine. But this is a perfect opportunity to put to work some of those things that we just talked about. NM is another one. What about it? Okay. Now it just ran by itself. What did it do? It picked up my A.out. Okay. What are some of the flags on that one? Do I have demangle? That looks fun. What's demangle do? Demangled. A little shorter. You're not going to hurt anything. Just play with this stuff. Tinker with it. We're having an informal computer science meeting today. Right?
Yes.
Yeah. We got to get everybody through the training so the club can stay alive. Including me. Hmm. Does anybody know what DLLs are? Dynamically linked libraries. And there's DLLs all over your Windows system. Mhm. There's your most straight objects, that's good. You're gonna need to save temps. Ah, yeah. There it is.
I'll have to come in because I'm work attendance.
Oh,
I
yeah.
have everything. Thank you.
No time accumulated. This is too fast. That's how you use gprof. So you use gprof, you compile it with PG, then you run it once. And then you have a new file called this gmon out. And then you can take that and actually display it by using gprof, the name of the output file, which was I_G, and then the data file, right? Did I get that right? Or is it the other way around? Data file, executable, yeah, and then the data file, gmon. And then it displays it of what it was. And then what it's telling you is that this particular piece of code has a flat profile, so there was no time accumulated in it. Okay. Be a fun one to play with a little bit. The gprof is a tool that's used on your source code. So you compile it and run it, and it will profile your source code, and it shows you where your time in your functions are being spent. That's fine. Yeah, no worries.
Should I pass this around?
Yeah, you can go ahead. Yeah. Yeah, go ahead and pass it around. I keep forgetting to pass that thing around. Thank you. Wow, that's cool. The other way. Thank you. Hmm. Marriage.